Good morning, myself Shagila Devi, Assistant Professor in Rohini College of Engineering and Technology. Today we are going to discuss about the subject CS3401 algorithms. In this particular subject, today we are going to discuss about the topic bin packing algorithm. So what is the outcome of learning this particular topic is, on successful completion of this module, the student should be able to summarize different bin packing problems. So before entering into the algorithm, we must know what is bin packing. So in this problem, they will give you a bin with the size. The maximum size is given for a bin, and they have given some data. So you have to fit the data within that bin. So what is the objective of this problem is, we have to fit the data with the minimum bin. So for that, we have so many algorithms. In this lecture, we are going to see two different algorithms. One is first fit algorithm, another one is best fit algorithm, and we are going to see what is the difference between these two. And we are going to I'm going to explain this with an example problem. So consider a problem. So we have a bin size of 1, and we have the data 0.5, 0.7, 0.5, 0.2, 0.4, 0.2, 0.5, 0.1 and 0.6. So the first fit algorithm is, so first we have to place the 0.5. So we have to create a bin and you have to place the 0.5 there. Then we have to place 0.7. So when you place 0.7, search from the first. So when you search the first position, we don't have place for 0.7. So we have to create a new bin and we have to place it there. And if you take 0.5, so search from the first bin, we have a place in the first bin. So you have to place it in the first position, so it's completed. So the total capacity is 1. So now the first bin is completed. So next we have the data 0.2. So first try in the first position, there is no space in the first bin. So try the second bin, there is a space in second bin with the 0.3 size. The data which we are going to store is 0.2, so that you can place it. So place the data in the second bin. Now what is the next data? The next data is 0.4. We cannot place the 0.4 in the first bin, so there is no space. Similarly, we cannot place it in the second bin also, because in the second bin we have only space for 0.1, but we have to store the data with the size 0.4. So we have to create a third bin and you have to store the data there. The next data is 0.2. So check with the first bin, there is no space. Check with the second bin also, there is no enough space because it has only 0.1 space. Now the data which we are going to store is 0.2. So try the third bin, we have space in third bin, so you can place it there. And then after placing 0.2, what is the data we have is 0.5. So you cannot place it in the first position, second position also, third position also. There is no space because we have only 0.4 space there. So we have to create the next fourth bin and you have to place 0.5. What is the next data? The next data is 0.1. So try to place it in the first bin, there is no space. Try to place it in the second bin, there is a space. So you can place it in the second bin. Always remember that you have to try from the first. Okay, so what is the last data? The last data is 0.6. So the last data is 0.6. So where we can place the 0.6 is, so you cannot place it in the first position, you cannot place it in the second position also, you cannot place it in the third position, and you cannot place it in the fourth position also. So you have to create the fifth bin and you have to store 0.6. So how many number of bins needed for solving this problem by using first fit is, we need 6 bins. And next is the best fit algorithm. So in this algorithm, you have to find out which is the best place for saving. We are not going to start from the first. We are going to analyze all the bins and which place fit best is we are going to choose. That is what we call it as best fit algorithm. So we are going to take the same problem. So first, if you take 0.5, you have to create a bin and you have to place it there. When you take 0.7, there is no space in the first bin, so create a second bin. Next, when you take 0.5, search from the when you search, compare to two bins, we have a place in only the first bin, so you can place it in the first bin. Next, if you take 0.2, you don't have a space in the first bin, so you can place it in the second bin. Next, if you take 0.4, you don't have a place in the first bin and the second bin, so you can create a third bin. Next, you have the value 0.2. So try to place it in first bin, there is no space in the second bin also, so place it in the third bin. Then you have the value 0.5. So when you take 0.5, there is no space in the first bin, second bin, and also in the third bin, so you can place it in the uh, fourth bin. And if you take point 1, you can place it, you cannot place it in the first bin, and you cannot place it in, you can place it in the second bin. And if you take point 6, there is no space for in the first bin, second bin, third bin and fourth bin, so you can place it in the fifth bin. So here also for this particular problem, it takes both the algorithms takes 4 bins. But when you solve some other problems, always the best fit algorithms which will give leads you a better solution compared to the first fit algorithm.